Hi dear students, good morning. This is yours 𝙘𝙀𝙀. Yes. In this class, we have to discuss some of the basic concepts of 7th, 8th and 9th class. Yes, which is related to one class. In 7th class, we have the chapter is motion. That means concepts of the motion is completely related to 8th class and 9th class. We have one chapter in 8th class also about graphs of motion. We have one chapter in 9th class directly motion, again one chapter laws of motion is there. That means in the physical science, it is in a most important concepts, but we have to require that more basics from the beginning. That's why in the previous classes also we discussed about that motion some concepts. Once more we have to revise that concepts and we have to discuss some other concepts also. As try to remember every class students of 7th, 8th, 9th, it is in a correlated concepts are there. One by one we have to learn. And some of the practice questions also I can forward along with this video. You have to try to answer them in our running notes. Yes, we already studied in the 7th class, yes, and 8th class. So those who are studying in the 7th class, no need to worry about that remaining concepts. We are starting from the basics. Yes, about that motion we have to discuss. What about motion? Yes, here I am writing once more motion. Yes. Motion mean what? Motion. Suppose, what is my position? Sir, you are standing, sir. Yes, I am standing in position. But is it in motion or in rest position? No. I am not changing my position with time. Simply I am standing here only up to a certain time. So I am in which position? In the rest position. As you are watching my video continuously up to 15 minutes or 20 minutes, whatever it may be, not moving, not changing your position, simply you sat in the sofa set and watching continuously. Yes, you are also in the which position? Rest position. Suppose now I am coming in front of you and moving back. Now I am in which position? In the motion, because of I am only changing my position with time. When any object is changing its position with time, is that we have to consider as it is in the motion. As any object, it does not change its position with time, that is in the rest position. Yes, simply sleeping 6 hours or 5 hours continuously. As you are not changing your position with the time, so you are in the rest position. As you are walking, you are running, you are jumping, yes, in every second you are changing your position. That's why you are in the motion. As you have to give us some of the example for rest position. Sir, I am only sat, sir. Simply, yes, rest position. Your bicycle also kept it in the room. It is not changing its position. It is in the which position? Rest position. Yes, chalk piece is there in my hand. It is also not changing its position with the time. It is also in the which position? Rest position. Give an example for motion. Sir, bus is moving, sir. Yes, moving. I am also walking, sir. Yes, you are also walking. These are also in the motion. Simply you have to keep in the mind. Object change its position with time. With time changing its position. Change the position with time. It is in which position? Yes. Change position with time in the motion. Yes. Clear? Yes. Not changing its position. Not change its position. Its position. Not change its position with time. With time. Yes. It is in the rest. Yes. Please try to write 5 examples for rest position. Please try to write 5 examples for that motion. Any example you have to write. For these 5, different situations you have to write. Sir, moving car, moving bus, moving aeroplane. Don't write like that. Similar example. Try to write some other different kind of the examples you have to try to write. Yes. What I told? Example for rest position, example for motion. Okay. Here, object is here. A position of the object is at A. Moving up to here it's reached. B. What is the distance of this object? Any object, X object is there, it started from A and reached to B. What is the position? What is the distance? S. Its position mean moving, mean in the motion. Yes, it is motion. It is in the motion. Reached up to here and stopped here. At this situation, it is in the rest position. It's clear. What is its covered distance? How can we tell covered distance mean? I already told in the previous class. Once more, I am repeating here. The length between initial point and final point. Length between initial point and final point, that we have to consider as a what? As distance. What is that? Distance. Length between initial point and final point, that we have to consider as a distance. It is in a point A and it is in a point B. The object is moving from point A to point B. Suppose you moved from your home to your grandmother home. The length in between your home to your grandmother home, that we have to consider as a your distance. Your distance. You started your journey from your home to your grandmother home, continuously walking, mean you are in the motion. Yes, after reaching to your grandmother house and simply sat on the sofa. At the time you are in the rest position. Simply how I am defining the length in between the initial point and final point, that we have to consider as a distance. What are the units of the distance? Centimeter, millimeter, meter and kilometer. These are the units of distance. These are the units of distance. Again one displacement. Again one is what? Displacement. What are the units of displacement? Displacement. Yes, what is meant by the displacement? It is an initial point A, moving and reaching here. It is in a final point. Yes, shortest distance in between initial point and final point. Shortest distance in between initial point and final point, that we have to consider as the shortest distance in between the initial point and final point. We have to consider as a displacement. Yes, actually your house is here. Your grandmother house also here only. But you started your journey in this way. In this way you reached. Yes. Yes. Which were here to you started continuously coming and reached to here. This is your traveled distance we have to consider. But there is a chance to come here to here also. Here to here also. Shortcut method. Yes. Back to here directly you came. It is a displacement, that we have to consider as a what? Displacement. One only distance, again one only displacement. A shortest distance, I am only telling. Shortest distance of in between initial point and final point, we have to consider as a what? Displacement. What are the units of a displacement? Displacement units are centimeters, meter, millimeter and kilometer. Centimeter, meter, millimeter and kilometer. Yes, centimeter, meter, millimeter and kilometers. These are the units of the displacement. Some more concepts, some more relationship in between distance and displacement also we have to discuss. Yes. First situation, distance is more than displacement. Distance is more than displacement. Second one, distance equals to displacement. Distance equals to displacement. Third one, distance less than displacement. Among these three, which are correct? First statement, distance is greater than displacement. Displacement is less than distance. Yes, we already defined this is an initial point A, it is in a final point B. Like this only, total covered length is distance. Shortest distance in between initial point and final point we have to consider as a displacement. Yes, that's way distance is always greater than displacement. Displacement always less than distance is the right statement. Second statement, distance is equal to displacement. Distance is equal to displacement. That's mean distance equals to displacement. Or is it possible? Yes, it is possible when the path is in the straight path. Any object, if it is move in the straight path at the time, distance and displacement both also similar. Both also similar. It is in a point A. It is in a point B. Yes, you started from point A and moving and reach to here. Okay, point A and point B moving and reach to here. Yes, here distance and displacement both also same. Why it is same here? A to B, distance and displacement both also same. Why it is similar? Because of there is no shortcut methods. There is no shortcut methods. Only one way, one path only there. That's way distance equals to displacement and displacement equals to distance. Both also similar. When it is in the straight path, exceptional case, we have to try to remember. Third one, distance is less than displacement. Is it impossible? It is an impossible. Distance always more than displacement. Some situations in the straight path only it should become as equal. Yes, it is in a wrong way. These two situations only possible. Only these two situations only possible. Is we got the distance and we got the displacement. Next one, speed and velocity. Speed and velocity. Yes, we have to try to remember speed and velocity. Yes, here the speed. Yes, here the velocity. Is distance by time. Distance by time is considered as a speed. Yes, here you are right, distance by time. What is that? Distance by time. Velocity, displacement by time. Displacement by time. Yes, it is only distance by time. Here I am writing distance by time. Distance by time. Okay, again one, velocity means displacement by time. Displacement by time. Distance by time in meter per second. Units for this speed is meter per second. Displacement by time, these also units are meter per second. Meter per second and meter per second both also same. Speed means distance by time. Velocity, displacement by time. Both units are meter per second and here also meter per second. Both also similar. Next, average speed. Average speed. Total distance by time. Total distance by time. total distance by time with we can get that average speed. Small mathematical problems we can get 1 mark questions. Is average speed mean total distance by time, you already learned in mathematics. Next one, average velocity. Average velocity is total displacement by time. Total displacement by time. What is that? Total displacement by time. Here average speed mean total distance by time, average velocity mean total displacement by time. That also we have to keep in the mind. Here also we can get 1 mark mathematical problems also we can get here. Next concept, acceleration. Rate of change in velocity. Rate of change in velocity is considered as a what? Is acceleration. Rate of change in velocity is considered as a what? Acceleration. Rate of change in velocity. Suppose if any object is in the rest position, what is its acceleration? Sir, it is in the rest position, mean there is no acceleration. Because of what happened here? Acceleration mean rate of change in velocity. Velocity mean displacement by time. There is no displacement. How we can tell the acceleration? If the object is in the uniform motion, acceleration also 0. When the object is in the rest position, also acceleration is 0. Sir, why when the object is in the uniform motion? At the time, uniform motion mean constant velocity, constant speed. There is no change in velocity. That's why when the object is in the uniform motion, when the object is in the rest position, at the time the acceleration should become as a 0. Is rate of change in velocity is considered as a what? Acceleration only. Acceleration is 2 types. Acceleration is how many types? 2 types. One only positive acceleration, again one only negative acceleration. Positive acceleration mean velocity should be increased as a gradually when the train is leaving from railway station and aeroplane also leaving from airport is when the aeroplane is leaving from airport, at the time you have to consider that one, its velocity will be gradually increasing and moving. Train which is leaving from the railway station, its velocity also gradually increasing. That's way if the velocity is gradually increasing, that we have to consider as a positive acceleration. If the velocity is gradually decreasing, mean that we have to consider as a negative acceleration. Here positive acceleration, it is a negative acceleration because of velocity will be gradually increasing. Here velocity will be gradually decreasing. That means the rail which is coming to nearby the railway station, its velocity will be gradually decreasing. If its velocity is gradually decreasing, that we have to consider as a negative acceleration. Like that only, if the velocity is gradually increasing, mean positive acceleration. As usual, the plane which is landing in the airport, at the time its velocity will be gradually decreasing. When it is gradually decreasing, that we have to consider as a which acceleration? Negative acceleration. Simply increasing velocity, gradually changing, that is positive acceleration. Decreasing velocity, gradually changing, that also negative acceleration. See, small difference. Which is leaving from railway station, positive acceleration. Which is coming nearby the railway station, negative acceleration. Again, one thing I told here, uniform motion and non-uniform motion. What is meant by the uniform motion and non-uniform motion? Uniform motion mean equal distance, equal time. Equal distance, equal time. 1 hour only I am reaching 60 kilometers. Exactly 1 hour I am reaching 60 kilometers. In next hour, second hour also I am reaching 60 kilometers. In third hour also I am reaching 60 kilometers. In fourth hour also I am reaching 60 kilometers. Equal distance, equal time. Equal time and equal distance. It is in the uniform motion. Suppose next situation, 1 hour in I reached 90 kilometers. Again second hour I reached only 30 kilometers. Is it in the uniform motion? Non-uniform motion. Equal time, unequal distance. Equal time, unequal distance. Non-uniform motion. Non-uniform motion. It is in which motion? Uniform motion. It is in which motion? Non-uniform motion. Equal distance, equal time, uniform motion. Equal distance, unequal time. Otherwise, equal time, unequal distance. That is also non-uniform motion. Again one, unequal distance, unequal time, also non-uniform motion only. Simply equal distance, equal time, uniform motion. Equal distance, unequal time, unequal distance, equal time, again one, unequal distance, unequal time. In these three cases also non-uniform motion. Simply in the notebook you have to try to write uniform motion and non-uniform motion. Here uniform motion, uniform motion, equal distance. Next, equal time.